Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work. Thanks again for making this one of the most downloaded podcasts about the future of work. If you enjoy what we do, please like, comment, and share in your favorite podcast app. And we'll keep sharing great conversations like the one we have for today. I'm your host, Dan Turchin, advisor at Insight Finder, the system of intelligence for IT operations, and CEO of PeopleRain, the AI platform for IT and HR employee service. We learn from AI thought leaders weekly on this show. And of course, the added bonus is you get one AI fun fact each week. Today's fun fact: leading computer scientists claim AI will outperform humans at every task within 45 years. As you know, if you listen to this show frequently, I don't believe in a future where machines replace humans. I believe in a future where machines augment humans. Research from the World Economic Forum poses 6 alternate visions for a future of work that's quite different from the present of work. For example, the overall output of society at large will be vastly greater in 45 years than it is today. That output can be used to eradicate poverty and hunger, both outcomes that are unimaginable without technology advances that will be driven by AI. I'll link to the full research paper in the show notes. I encourage you to read the report. My takeaway: advances in AI are nothing but a reason to be optimistic about the future of humanity. Now, shifting to this week's conversation, software and hardware robots are being trained to do tasks humans either aren't good at or ones that we just don't want to do. We often refer to tasks that are good candidates for robotic automation as being dull, dirty, or dangerous, the 3 Ds. As we reimagine manufacturing, shipping, and supply chains, it's really important to consider not just how the technology will work, but also the implications of it on the humans performing those tasks today. One of the companies at the forefront of imagining how industrial robots will improve how products are made and distributed is Zebra Technologies, a 9,800 person, 53-year-old company that has taken the lead in innovations related to enterprise asset intelligence. If you're like me, you mostly know Zebra as a barcode scanning company, but that's really just the beginning of what they do today. We're lucky to be able to discuss the future of robots in the workplace with the general manager for robotics automation at Zebra, Jim Lawton. Jim's a seasoned technologist and one of the foremost experts on the topic, having spent time at Rethink Robotics, Universal Robots, among others. Jim has 2 master's degrees from MIT, and he did his undergrad in EE at Tufts. And without further ado, Jim, it really is my pleasure to welcome you to the podcast. Let's get started by having you share maybe a little bit more about your background and how you got into the space.
Yeah, thanks, Dan. Thanks for having me. I'm super excited to be here. My background. After MIT, I've been in 4 big companies and 4 little companies. I sold one of my startups to a company called Dun & Bradstreet, a company that many of your listeners may have heard of, and ran that business there for several years. And then I got a phone call from Rodney Brooks. Now, some people in the robotic space might know Rodney. If you've got a Roomba vacuum cleaner running around your house, Rodney was one of the co-founders of iRobot, the company makes the Roomba, and I actually knew him from back in my time at MIT. He was the head of CSAIL, which is the Computer Science and Artificial Intelligence Lab. And so, he gave me a call and was looking for someone to come help him at a company called Rethink Robotics. And to be totally honest, my feedback was, robots have been around for a while. I'm not sure that's something I want to do. I mean, the first robot was put into a real production environment back in 1961. And, they're, big, heavy, complex arms. You get in the wrong place at the wrong time, you get hit by them, and that usually turns into a bad event. I expressed some reluctance, but Rodney, anybody knows him, he's a persistent guy. He said, let's catch up and let me tell you a little bit about what I have in mind. So the vision that he had was really, sort of at the forefront of the change that we've now been seeing over the last 10 to 15 years in the in the robotic space. And so that was my first robot company. Haven't looked back since then. As you mentioned, currently I'm running a robot business for Zebra, and having a great time. And like most people in the robotic space, we have our favorites. I've been watching Obi-Wan Kenobi. R2D2 was probably my first exposure with some mechanical cool robots sort of running around, and that's one of my favorites. And it's I've got two children, and it occasionally puts me into the cool daddy position of my dad works at a robot company. So so I've been doing robots and having a great time. It really is a great time to be in the robotic space right now.
So Jim, I dated myself in the intro. I said I really only know Zebra as the barcode scanning company. Give us an example of some of the work that Zebra's doing in robotic automation that makes you most proud.
Sure. So let me give you an example from a real company. There's a company that makes electrical wiring supplies, fasteners, connectors. They're a distributor up in the Midwest, up in Minnesota, a company called Waytech. They largely sell to OEM automotive companies, agricultural vehicle manufacturers, and they had built a building where they were doing distribution of their goods. I think they had built it, I think it was in like 2007. And so it was designed to handle a certain number of orders per day. And they were experiencing growth. And, for them, it was, how do we meet the increase in demand that our customers are pulling on us, and yet do it in in an efficient way. And so, like a lot of people that run warehouses and manufacturing, they took a very deliberate approach and said, hey, let's see what our options are. We could add, and they had conveyors throughout their warehouse, so that they had a conveyor sortation system. And they said, well, look, we could add more of those, but we don't actually have a lot of, floor space for that. We could add, additional sort of traditional, automation, but that tends to be more expensive and it tends to be more flexible. And so then they looked at the opportunity of, what might we be able to do with AMRs. So AMR are autonomous mobile robots, and unlike HEVs, which you can sort of think of as, they're robots that almost operate like trains. They operate on a track, so they have to follow something that guides them around. AMRs are a lot like autonomous cars, and so you help them sort of understand their environment. They create a map of their world, and then you give them tasks. I want you to go from point A to point B, and you go navigate around. And so if there's a person somewhere, or if there's a forklift somewhere, they'll navigate around them because they know what they're being tasked to go do. And so they really got excited about the opportunity to how can we address capacity and do it with AMRs that provide us not only that lift, but they can do it cost effectively. They also allow us to to keep flexibility. And so as we set up new routes or set up new pick locations, or we bring new products into the portfolio, you can do all of that in a very flexible way with with no increase in capital investment, and it doesn't take a lot of time. You don't have to go hire somebody to go do it. And so they ended up bringing AMRs in, and so we're a proud provider of Waytech's AMR solutions, and they have them doing a variety of things. On the inbound side, they have them receiving components and then bringing them to carousels. They have them from the carousel pick locations. They have them taking items to a put wall, and then they also do things like dunnage, which is the industry's way of saying take out the trash. And so you push a button, the robot comes, picks up the trash, and takes it to the other side of the building. And so all of these examples that I just talked about, they were all done in about 3 days. From start to finish, they were fully up and running on day 4, and they were able to increase their capacity by 25% in that facility, which, according to their estimates, is going to allow them to stay within that existing building for another 5 to 7 years. And so For us, robots are a means to an end, as hard as it is as a robot guy to say that. I mean, they're there to solve a business problem. And the business problem these guys had was we need more capacity. It's a very competitive market. We have to be super efficient in doing it. And they chose AMRs as the way to go about doing it.
So we're recording this in June of 2022. And just in the past day or so, a Google engineer, a guy named Blake Lemoine, came out and scared a lot of people. He said the Google Lambda bot just became sentient. We can debate what the meaning of a sentient bot is, but that aside, there's this kind of cultural zeitgeist about how robots are going to take over the world and replace humans, and they're out to get us. I say I don't espouse that vision, and I'm guessing, Jim, you don't either. But just speaking pragmatically, what do you think are some of the fields that are good candidates for being replaced by robots? And then, more important, are there others where you think the introduction of industrial robots will create new opportunities for humans that don't exist today?
Mm-hmm. Yeah, so I mean, you mentioned in your introduction sort of dirty, dull, and dangerous, and that's been a phrase within the robotics industry now for a while. It's interesting because of the way robots and automation have been traditionally deployed. They're fairly complex. They're complicated implementations. They take a while. They typically tend to be fairly custom. And so there's a level of expertise that you need in order to be able to make good use of robots. And so for a long time, about 65% of all robots were used in large automotive firms, because they had the environment, they had the expertise, they had people, that were able to design their manufacturing and logistics processes around the robots. And so, the example I like to use is if you've ever seen the movie Apollo 13, at one point, the astronauts get stuck up into space and they got to figure out how to come back down again. The engineers on the ground sort of dump out a collection of parts and say, all right, so with this stuff, how can we get these astronauts back down to the Earth again? Robot implementations have traditionally looked like that. And so you've got a bunch of parts, you've got a robotic arm, you've got sensors, you've got cameras, you've got a PLC, which is a programmable logic device. And then you physically have to put all of this stuff together. You have to electrically get it all together, and then you have to program it. And typically it has taken, on average about 300 hours to program a robot to do a thing. And that set of circumstances, those parameters lock out a lot of people from being able to take advantage of robots. And so if you're not in automotive, and if you're not a large company with a team of roboticists or advanced degree automation engineers, you couldn't take advantage of robots. And so a lot of the work that's happened over the last 5 to 10 years has been, how do we make robots that don't require that level of expertise? I mean, as an industry, we've really sort of dumped this engineering exercise onto companies to go figure out, how do I get this robot to work for me? How can we make them flexible so that I can do something with a robot in the morning and do something different in the afternoon, or if I want to change them from one workflow or one process to a different workflow or a different process, make them inexpensive enough so that they can, that the ROI, the payback is actually there. And then the other aspect, anybody that's run a manufacturing environment or warehouse will tell you, stuff that is not perfect. It's like a house with perfect corners. They're not always perfectly square. And so you have to be able to deal with the variability that's typical in most manufacturing and and warehouse type environments. And this is where the technology has really helped us over the last several years. I mean, if you think about the iPhone that's in my pocket, it's got accelerometers in it. The development of the iPhone has led to lower cost and higher performing accelerometers that those of us in the robotics industry are also able to tap into. And now we can use advanced cameras that have come out of many of these industries and accelerometers and other sensors to do things with robots that couldn't have been done before. So if you think of things like, I mean, as humans, we're not particularly precise. I mean, if I were to try to move my hand through space, it would be pretty inaccurate. It's certainly compared to a robot. And yet I can do tasks that require, high precision. I can put something into a slot that has 100 micron clearance. But the way I do it is a combination of visually looking at what I'm trying to do. And then I have amazing sensors in my hands to be able to sort of feel my way into that spot. And so although as a human, I'm not a particularly precise creature, I can do really precise tasks. What we're starting to see with robots as the result of AI and advanced vision systems and advanced sensors, we can train the robots and help the robots to be able to perform tasks that they could never do before. And so all of a sudden, all of these tasks in all of these industries that historically haven't been able to take advantage of robots are now able to. And so, as somebody in the robotics space, this mission of democratizing automation, making it available, making it accessible to so many more people, and in some ways leveling the playing field so that it's not just the big guys that end up with the robots, it's everyone that can end up with the robots. I think it's such a tremendous opportunity for companies. And so, people that have never been able to take advantage of a robot, can now do so.
So you mentioned that industrial robots have been in factories for 60 years. So the notion of robots doing labor in manufacturing settings is not new. But the idea that robots and humans can collaborate in factory settings, I think that's a little bit more opportunities for pioneering kinds of use cases. How do you think about collaboration between robots and humans, and where has the field gone, let's say, in the last decade?
Mm-hmm. So traditional industrial robots are and can be very fast, very precise, carry very heavy payloads, and can be very dangerous. And so in a lot of circumstances, in order to be able to protect people, you have to keep the robots and the people separate, which is almost the antithesis of collaboration. So the robots do their thing and the people do their thing, and they can't be near each other, because if they do, the person could be potentially get harmed and and in some cases killed. What over the last decade or so, the field of collaborative robots is now allowing people and robots to work together in the same environment in ways that can be done safely, for people. And so that this segment of the market is typically referred to as collaborative robots. There are collaborative robotic arms. There are collaborative AMRs, like the ones that that Zebra makes. And there are standards to govern safety around these collaborative robots. If you think historically, because robots didn't operate in this kind of a way, the standards didn't really accommodate. And so there are new standards that have come in place specifically to be able to address the collaborative, robotic needs. And so now you can have people working side by side with robots. And what I like about the opportunity that this has provided for us is that, again, coming back to the dirty, dull, and dangerous, there are a lot of jobs that people don't like to do. In some cases, can be unsafe. For example, like inserting a piece of sheet metal into a press brake. You put your hand in the wrong place at the wrong time, and you can lose your hand. And so people are really good at some things. And for example, picking an item off a shelf, for example, you would think that would be relatively straightforward. But if you've got a heterogeneous set of items sitting on the shelf, I have to figure out, which item, how do I grasp it, how do I squeeze it, and how do I selectively sort of take it from where it is and then put it to where it needs to go. Those are things that are actually really hard, for a robot to do. And can they be done by a robot? Yes. Can they be done Can they be done by a robot quickly? In many cases, the answer is no, or certainly not yet. And so you have environments where you want to have people doing what they're really good at, and then have the robots do the rest. So for example, like picking in a warehouse, more than half of the time of a human picker in a warehouse is spent running up and down aisles, getting to the point where they can do a pick of an item and put it into a tote or put it into a box. And so you have, people that are spending a whole lot of time walking, a bunch of time, searching, and then they do a small amount of time picking. And yet the part that people are really good at is picking. The part that they don't like doing so much of is, 12 to 15 miles a day worth of walking. And so it's a great opportunity to say, let's have the robot do the running around. Let's have the robot assisting with, I'll help show you where the right spot is, and then have the human doing the picking. And so there are sort of example after example of cases where now, because you can have people and robots working side by side in a safe way, all of a sudden you can open up all of these tasks, that were never possible before, because you had to keep, half an eye toward, or more than half an eye. You had to be very specific from a safety perspective to make sure, you weren't necessarily putting the people in harm's way.
So traditionally, robots are pre-programmed to do very finite, call them deterministic tasks. And so with regard to worker safety, it's typically the worker that needs to be trained, and the organization training the worker is presumably liable if they get in the way of something the robot was trained to do. Now that we introduce the notion of a smarter robot or robot that could potentially learn, they're I don't want to leap to the conclusion here, but I think they can exercise non-deterministic behaviors, learning behaviors. In that case, when we think about worker safety, where a robot may do something that it wasn't explicitly programmed to do, who's liable if a robot learns to do something that subsequently harms a human, even if the human was trained, because nobody knew what the robot might do eventually?
Yeah, so there's an important aspect of deploying a robot that becomes really important. What I would tell you is there is no such thing as a safe robot. There is a robot that can be deployed in a safe way. And so if you think of any robot, whether it's a traditional industrial arm, a collaborative robotic arm, if I put a knife into that robot's arm and I start swinging it around, I can hurt somebody. And so the robot performing that task is not safe. And so the responsibility really lies with the person who's deploying the robot to do an appropriate assessment to make sure that the task itself can be performed in a safe way. And if it can't, then that's where you put in, whether it's light curtains or guarding, to provide the appropriate type of protection. So there's a lot of responsibility that lies with the person implementing the robot deployment, to make sure that it really is a task that can be performed safely. Many tasks can. Some of them are just not good candidates for robots without providing some type of protection for the people.
I asked about new fields that may be created by the introduction of these collaborative robots. Talk to us about what kinds of opportunities there are for humans to look at what robots are learning and evaluate the performance of these robots, feed them data. It would feel to me like, to keep workers safe and also to make sure the robots are used effectively, there must be a whole new set of opportunities for humans to interact with robots.
There really are, and there's a whole sort of range of possibilities. So within the manufacturing environment, within the warehouse, there was a study that I looked at not too long ago, and I wish I could remember the source of it off the top of my head, but it looked at and reached out to Gen Z and millennials, and it asked the question of, what are the kinds of roles that you're interested in? What are you looking at doing from a career aspiration perspective? And I probably won't quote the figures exactly correctly, but the number of people interested in roles in manufacturing environment was around 3%. Those interested in warehouse operations and logistics was, as I recall, about 1.5%. And at the top of the list, the number one thing on the list was opportunities from a STEM perspective. And so if you look in many of these manufacturing environments, take, for example, the person operating the press brake that I talked about a few minutes ago. They put a piece of sheet metal in, comes down, makes a bend, take it out, put it aside, pick up another piece of sheet metal, put it in, comes down, bend it, take aside. So it's that very repetitive over and over and over again opportunity or task. If there's a way to have a robot do that task, now all of a sudden you've freed up the person to do something else. And if you have multiple robots, now what you have is a need for someone to manage a set or a fleet of robots in a manufacturing environment. We've created a role that's at the top of the list for people coming into the workforce, not near the bottom of the list. And so I think there are roles within these environments, within manufacturing, within warehouse, but then also in the development of the robots themselves. Historically, robots were trained and coded in a very specific way. When you train a robot today, one of the ways that you can train a robot is by almost like on-the-job training. You show the robot how to do the task, it remembers your task, and then, oh, by the way, it optimizes your task to do it even better than you trained it, because it has ways of making that more efficient. And so for some of the robots, the robotic arms, you can hold on to their wrist and then move it through space, tell it to activate its hand, pick something up, move it to another location, tell it to let it go. You haven't done anything with a computer screen, you haven't done anything with a mouse, you haven't done anything with a keyboard, and yet you've trained a robot how to do a task that it doesn't know, that it's never done before. And so you have people that are training robots in this way, doing things that they find exciting and engaging and creates career opportunities. And then you also have the engineers that are designing the robots to do these things, because to make it that simple to be able to train a robot on the back end is really, really hard. And so, from perception and vision, AI, in the AMR space, so SLAM, which is the simultaneous location and mapping, that's what allows the robot to operate in an autonomous way, but also, hand-eye coordination. If you think about, parts coming down a conveyor, what are the chances they're going to be in precisely the same place every time? In many cases, they're not. And yet you and I could look at the part and we could pick it up, even if it's rotated a little bit or if it's a couple of centimeters one direction or the other. Building and innovating the technology to figure out how to get robots to do that, is an incredibly sort of dynamic and vibrant, field right now. And so companies are, pushing the edges of, let's figure out how to do more and more complicated things that involve more and more, variability and ambiguity, and leveraging all of these technologies. Robots that learn from their experiences require you to be able to, collect data and leverage AI tools so that you're able to effectively give the robots the ability to benefit not only from their own experiences, but from other robots' experiences that are doing similar tasks. So all of a sudden you can have not just the benefit of that particular robot's experience, but fleets of robots. For a while, I used to run operations and supply chain for Hewlett Packard, and we used to have a saying inside the company at the time that went something along the lines of, if HP only knew what HP knows, think of how powerful that would be. I mean, there was always somebody somewhere that had faced a particular issue and dealt with it. But if I didn't, I was learning from scratch. What if all of a sudden I could know all of the experiences of all of my peers everywhere in the company and be able to have that at my beck and call when I'm doing something to allow me to do something better, or to start, from a place of experience from that others have had. We can start to build robots that do the same thing. And it's these areas that I think are so exciting, to people coming into this space right now, because this is all open territory. This is all new things that we're just, although there's been tremendous progress already, the progress that we're going to make is so much bigger, that's in front of us.
Recently, there was a video of a robot that went viral manipulating soft objects with n degrees of freedom, like Play-Doh or baking dough, baking bread, something like that. And it truly was astonishing to me. I'm curious to know, in your field, what are the hardest technological problems that you're solving? And maybe what are some of the technological barriers that you think are impenetrable, even looking out a decade?
A lot of the technological challenges are as a result of the environment that, the companies are trying to operate in. And, if you go into a typical manufacturing environment, if you go into a warehouse, you're going to see stuff everywhere. You're going to see clutter. You're going to see, if you're picking something off a shelf, you're not going to see perfectly aligned boxes. You're going to see stuff that's been ripped open. It's going to be hanging out over the edge. You're going to see a pylon that's been tipped over because it was there for some project earlier in the day. Somebody left a ladder along the side. There's a forklift coming at you. Being able to navigate in that kind of an environment where things are constantly changing. I once worked for a company and ended up getting a flat tire. And so I asked one of my buddies, I'm like, where can I get a flat tire fixed around here? He said, oh, you want to go to this place? It's just a little bit, beyond where so-and-so used to be. I'm like, look, I just started this job. I don't know where so-and-so used to be. In the environment that these robots are operating in, they can say, look, I want to take a right by this next pallet, but that pallet may not be there. And so you have to figure out how to navigate in an environment where things are constantly changing. And so I mentioned SLAM a little bit earlier, which allows robots to navigate in their environment. But in many cases, the aspects of the environment on the floor can change, but the aspects of the environment on the ceiling do not. And so if I'm all of a sudden using my cameras to focus up on the ceiling and looking for features and using that to help me guide myself, I can navigate around much more confidently because I'm able to have landmarks that are more static as opposed to things on the floor that are, can be much more dynamic. And so you develop the technology that allows you to do, in this case, ceiling SLAM, as opposed to more traditional SLAM, in order to be able to accommodate that level of ambiguity and change, the sort of the dynamic nature that you see inside these environments. In terms of long term, and I forgot who this quote comes from as well, but there's this idea that someone has said at one point that we tend to overestimate the impact of technology in the short term and underestimate it in the long term. And so over the long term, I think we'll see robots doing lots and lots of different things. I'm pretty confident though. People are really good and people are very adaptive. And so I think we're going to be seeing people in manufacturing environments. We're going to see people inside warehousing environments for a long time to come. So there are some things that robots they may eventually be able to do, but probably not over the next decade or so.
So you've got 2 kids, I've got 2 kids. Let me give you a hypothetical. So the 2 of us and our 4 kids walk into a factory because we're fascinated by this stuff and we want to see humans collaborating with robots. I want to know, from an expert's eye view, what are the first things that you look at that might indicate that they're not making responsible use of robots, or there may be some kind of safety issues?
Well, I'm often walking around inside environments, and this area of collaborative robots is really new. And so people that are aware of the robotic space and the traditional robotics, industrial arms, have built up over decades knowledge about what are the kinds of tasks that these robots are good at, what are the kinds of tasks where the payback is there, where the ROI is good. And when you're starting to talk about collaborative robots, you almost have to throw all of that away, because these robots operate in a very different way with a different sort of payback envelope. And so when I walk through a manufacturing environment, for example, there's 2 things that I look for first. The first thing I look for is, what is the person doing with their hands? Again, because we've just got really flexible and powerful hands in terms of what we can do. And there are and robot hands, end of arm tooling, as they're typically called, or grippers, aren't nearly as good as human hands. And although people have developed hands for robots that look and operate a lot like multi-degree or freedom that we have in our own hands, they tend to be complicated to program and they tend to be more expensive. And so in most cases, they're not a good fit for the particular task. If I'm trying to pick up like a flat package, typically the best thing to do is a couple of suction cups. You go down on it, create a vacuum, pick it up. Way simpler, way more reliable. So that's the first thing I do. What's the person doing with their hands? Second thing I actually look at, coming back to a point you made earlier, is the person doing the task smiling? I mean, do they really enjoy what they're looking to do? And so in a lot of cases, people will say, well, people inside a factory aren't interested in having a robot do a task. And I would say, yes, they are, because I've seen it time after time after time. You go into an environment and you ask somebody, what do you think we should automate? That task over there, or my task, and you can see it. You can see it on their faces. A common error that people make with collaborative robots is, I want to make sure I get value out of these. Let me go find the hardest, most complicated task I can and have them do that. In a lot of cases, the person doing that complicated task is one of your most knowledgeable people in the factory. And they know more about how to get that task to work better than anybody else. And oh, by the way, it's probably something that's really difficult for the robot to do. And yet, if you step a couple of feet to the right, you see somebody whose job it is to take a part off one conveyor and put it onto another one. Or they're at the end of a plastics injection molded machine. They're picking up a plastic part, they're doing a quick inspection, they're counting it, and they're putting it into a box. Those are the tasks that the people doing them are typically not smiling. I mean, we have a customer that I worked with a couple of years ago. The company was making medicinal cups. So if you were in the hospital and you had to have a couple of ibuprofen, the nurse would bring you one of these cups and they'd put two little ibuprofen sitting in there. These cups were just sort of streaming out of the machine. His job was to stack them, count to 100, put them into a bagging machine, take them out, and then put them into a tote. And so you can imagine doing that over an 8-hour shift. You're going to make mistakes. And so somebody somewhere is going to get, a bag full of cups that say there's 100 and there's really 98 or there's 102. And so those are the kinds of tasks that are just, not a good use of a person's talents, and an incredibly good, good fit for robots. So those are the kinds of things that I look for. There's sort of a special, focus on, our tasks being done in ways that are, unsafe. So from a robot perspective, there's a category of robots that are called power and force limiting. So if you think about how can I create a robot doing something unsafe, in addition to putting a knife in its hand, if I have a really heavy payload at the end of a really long arm moving really quickly, I can build up enough energy that despite the control system, even if I bump into somebody, I'm not going to be able to stop it quickly enough before I can cause harm. And so you can tell based on how heavy are the objects being picked up, how fast is that robotic arm moving, the circumstances that could potentially create an unsafe environment for a human. So you're always looking out for those.
Jim, I got to get you off the hot seat, but I'm not letting you leave without answering one last question for me. Back to your kids. So you mentioned at the top of the show that you're the cool dad because you work with robots. So I'm just gonna go on the record and say I'm not always the cool dad, but I'd like to be. Give me a cool dad story. So what's something that you tell your kids as being the robot expert that instantly gives you dad cred?
Oh, cool robot story. Oh yeah, sure. You saved this one for the end, didn't you? Well, so here's one of the things that I try to instill in my kids, and I think we all have sort of lessons that we've learned over our lifetime, and and being sort of particularly in this environment of the great resignation, right? And so many people deciding to either opt out or opt to do something differently. There was in addition to liking Star Wars, I also like all the James Bond movies. And in the most recent one, there was a saying about, the proper function of a man is to live, right? Not to exist. And I'm not going to waste my days trying to prolong my days. I'm going to use my time. And I think for many people, they've been thinking, am I living my best life? Am I doing what I want to be doing? And when I go through the factories and I see people that are not smiling, I see opportunities for us to use robots to supplement the work of people and allow people to be doing things that are a much better use of their skills. And so when I think about what I do every day when I come to work, and what I want to be working in a place where I can add value and create environments for teams to do amazing work, and provide returns to shareholders and all of those kind of things. But I like to work in an environment where there's a purpose, and I believe through robots we can make not only great value for companies, but better lives for people. And so, I think, as individuals, we all have to ask ourselves, are we leading our best life? And as business leaders, are we creating, the kinds of roles, to which people aspire? We all have to make money, but life is short. And so, do what brings you joy. And if through robotics, I can help people do the things that bring them joy, that to me feels like a life well lived. And so, if I believe a lot in, don't do what I say, do what I do. And so I care a lot about, the example I set, and hopefully in some small way, they're able to see, I tried to make the world a little bit better place, as a result of being here.
Jim, the time flew by. We were just getting started, and I thank you first for letting us go way off script. I don't think we planned any one of those questions, but it was a fascinating conversation, and maybe you'll come back and we can continue it sometime.
Thanks, Dan. I would absolutely love that. Thank you.
Jim, where can the audience go to learn more about you and your work?
Right to Zebra's website. So there's we have plenty of blogs, and some of that I've written, and some written by some of my colleagues. So these are the kinds of topics that we talk about.
Beautiful. Well, Jim, thanks for hanging out. That's all the time we have for this week on AI and the Future of Work. Is your host, Dan Turchin, signing off, but we're back next week with another fascinating guest.